So, impulse engines are used to place the satellite into an orbit with a longer period. Discuss any changes this makes to the orbital motion of the satellite. So, jumping across, what we've got then is we have got a satellite, I consider it a smaller mass, orbiting something with a bigger mass that's at a separation r. Now strictly should be from the centre of masses of these objects, and what they're telling us is the period increases, which is normally written as the capital T, and that increases, and they want to know how the orbital motion changes, and it's for 4 marks, so I'm going to have to make 4 points to actually pick all that up. Now, if I'm looking at this, I'm going to assume it's following circular motion, so the satellite's following circular motion. So I know that from circular motion I'm going to require a force, mv squared upon r, to actually maintain that motion. And it's a satellite, so this force is going to be provided from gravity, so I can use Newton's law of gravity. So I've got those 2 equations. Now I'm going to simplify them now. Let's get rid of the mass of the satellite because that doesn't matter, and I can get rid of one of the r's. So what I get is v squared is equal to gm upon r. So I know that v squared is basically proportional to 1 upon r. I don't care about these because the radius is kind of to do with the motion and the velocity is to do with the motion. But this doesn't actually help me because it's told me that the period increases, and I haven't got that in any in this equation so far. So the next step I'm going to look at is look at the velocity, see if that helps me. So I know velocity is distance divided by time. So that's the circumference divided by the time taken to complete orbit. And I'm just going to substitute that into this equation. So I've got 4 pi squared r squared divided by t squared is equal to gm upon r. Doesn't immediately help me in terms of what's going on, so I'm going to rearrange it. So I've got 4 pi squared, it's going to be an r cubed upon gm is equal to t squared. So I've got the r cubed is proportional to t squared. Now at this point I'm in a pretty good state because I can see how t is related to r, and I can see how r is related to v. So I've got a good explanation in terms of what's going on. So let's try and figure out what that means. I've got t squared is proportional to r cubed. So if I increase t, it's going to increase r. So as t is increased, r will increase. Now the second thing I can say from the other equation I've got is 1 upon r is proportional to v squared. So as r is increased, v will actually decrease. So as r is increased, v, the speed, will decrease. So in terms of the orbital motion, I've got at least 1 point there, 1 point there, but I'm conscious it's a 4-mark question. So I would be a little bit nervous if I was doing this in an exam paper. The reality is when you check the mark scheme, yes, there's 1 mark for that, there's 1 mark for that, there's 1 mark for that relationship, and there's 1 mark for that relationship. As such, 4 out of 4. Thank you very much.